Look at that. Melissa wants us to send her.
Can you check the YouTube link?
Other teams are, does anyone have an outdoor demonstration? Okay. Do you guys think that it would be better to try to do you guys first? Because it might get windier?
Yeah, Heidi's saying it's going to get windier the later we wait.
Well, then that
We can do
sounds
that.
like a very good candidate.
At least that's what I saw this morning on the weather.
So how many teams do we have?
Man.
Missing nominees. Missing the Hampton group.
With some Jess.
Missing Jess.
Jess is probably standing outside.
Yeah. Let me get the memo.
So we have the other side. We do have the other 6 teams. So you guys are on the same team. So there's 3. Actually, you're on their team as well.
Yeah.
We're 2 teams, 1 outdoors, correct? You guys and you guys?
Yeah.
You're 1 outdoors as well?
3?
Okay, so there's 5 groups.
I know ours needs 10 minutes of setup time.
Okay.
So we should go first, but we could go right after an outdoor and set up while they're out there.
Okay. All right.
5 teams over here.
Yeah, we're missing Jess's team. Mike
Jess is probably standing outside. And we're actually just, Wes's note said the other team is here.
Oh, that's right. We got 9 in
Yeah.
for today. All right. This should be good. Just make this. All right. Going to do a quick roll call. Local copters. Here. And you're outdoors.
Yes.
Narwhal vengeance.
Here.
Out, and you're inside.
Yes.
All right.
Tips is
Temps are
Jess.
not here. No comment.
Outside?
Kids gotta be outside, right?
No comment.
We want judges inside.
Judges outside.
We should find outside.
We have
That is correct.
Your presentation's inside.
Our presentation is inside.
I feel more
Inside the outside.
I feel no comments playing more games. There's Hampton. All right, Mike, are you guys doing indoor or outdoor?
Outdoor.
Okay. Gyrosaurs.
10.
Not here.
Cheers.
Rotor coasters.
Here, indoor.
Indoors. All right. Whirlybird.
One of us is here.
Okay. Indoor or outdoor?
It's outdoor.
Outdoor.
Actually, I could do both, but yeah, outdoor.
If it doesn't matter, we prefer indoor, but it's your call.
No, it's outdoor.
Okay.
So,
Space Cadets. They were the ones who did the
you
short.
missed out on some
No, that was-
No, that's Brian Moore.
Oh, that's right. Okay.
Tazo Robin. Gyrosaurs were the ones.
Gyrosaurs were not. Okay, they're not here now. So we're missing Space Cadets, Gyrosaurs, and Pellets.
And of the outside people, you guys have an indoor presentation?
The presentation is here. Indoor.
Anyone else on the outdoors?
Did you cut the plant?
Need to- Any of the other outdoor people have to present? Do any of the other outdoor teams have to present indoors? Outdoor solely? So we
All right.
have to have that. Can you need to present it? Outdoor demonstration? Yeah.
They are second.
But we need to stay here.
Correct.
So it's a good presentation.
Oh, okay. So we weren't clear.
Our
So,
solution is long way.
got it. How many teams need the judges outside? That's what we really care about. And forgive me, but you guys team is outside. So we'll be outside of that. And your team was Whirlybird, and you want us outside. Okay.
And so no comments.
Yes, absolutely. Absolutely. And when we see presentation, we don't necessarily need slides. If you guys just talk us through what you did, that's fine. It's a very important.
Yeah.
Interpret the image is an extra 20 points.
Is it really?
That's not
It depends on the workload.
That's what
I'm so used to
Michael, you want judges outside today?
We can do it after.
All right, so definitely outdoors first. We will do, so all the outside teams and the judges will go out. The inside teams, you guys can either go get your work done or hang out, whatever you want. Probably gonna be at least 30 minutes before we do the inside. So we'll go outside first. We'll do the local company first. Then the meeting room. Then we go. Okay. Someone willing to loan me a drone or
We can make this third, we throw
Okay.
There's is not.
Okay, as long as we're all batteries.
Well, that's true. You might have
So if you got a good strong battery. Yeah, the extended life battery.
Yes. Yes.
Did I suggest that actually outside the transition first?
Okay.
Then we can set up, we have some outlets set up.
I don't understand.
Absolutely. What's your team? Okay, so you guys are first. You're fourth total, first inside. All right. So if anyone sees zero stars, basically they need to go outside and have about meetings. We'll try to track it out as well. We'll try to track it out as well. So, yep, local copters. Yep, local copters. Then and whirligig outside.
Okay, well, we're taking notes.
I have to. We have a copy of that.
Sounds good. Sounds good.
Yeah. Oh, okay.
No, we put it on.
Oh, wow.
I don't know what feels it.
So now I have to bring all of this. Do you need also that?
No, I swear up. No, I want this one.
I don't.
I think it's gonna go work. No, I said like you said, you had a ton of stuff to do. That's why you got me.
Yeah.
I wanna lie.
6 viewers.
Yeah. All right. Yeah. Good. All right, we're just about there. All right, so we'll see. Well, that one's dark. It's dark. That one's right. Or the red stripes might have confused it a bit. All right. All right. As soon as they give me a sign, we're ready to go. Given what happened yesterday.
Especially if you're wearing red.
Right, ready to go. Okay, Rafflecopter's presentation. Today in the U.S., there's 6.6 million blind or visually impaired individuals. The cost to get them a guide dog, one guide dog costs $42,000 to train and prep. We think drones could help the problem in this case. If each person got a guide dog, $257 million in that expense. If drones are roughly $3,000, we could accomplish this task. We come at $19 billion, saving $258 billion for this type of problem. Okay. So what we want to show is how a drone could assist someone who would be visually impaired or blind. Randall is our subject. Now he's going to be looking at what's going on because we all saw how things moved around yesterday. If Randall, now what's going to happen is the drone is going to track Randall. As he walks, the drone will be, you can see it's facing backwards from what we were doing yesterday. So camera's facing him. If he stops, the drone's supposed to stop. When he moves forward, the drone, so it should keep this buffer between him and the drone. Okay? And we're just going to have him walk around a very simple course. But picture in your head, he's at home, he's going to go to Safeway, he's going to go to a place, and the drone is going to lead him there with GPS coordinates. So we mapped out the GPS points, and the drone is going to take him. Any questions? Okay. Jonathan, would you please call the dog? Oh, wind, victory, wind. The drone's going to pick up on the red shirt, and notice how it's following him back. Now, ideally, it's going to be coming down one of these points, but it's got a lock on it. GPS is the GPS. But notice how when he gets close, the drone backs up. It's a very friendly dog. Okay, that happens. Yeah. Back up. You're a little high for it.
I think our dog froze. A little bit chilly out here.
Flip it.
Yeah, flip it over.
Because it's, once it takes off, it's Michael.
People are saying the live feed needs to turn 90 degrees counterclockwise. I guess it's coming in sideways.
Okay. Let's see. Sometimes it gets stuck
You're in
on
the
one way.
shadow. If you want that, you may not care.
In 30 seconds, it should be better.
Okay. The other thing you'll notice is using voice commands. Start it up, stop it.
Wireless is cut out.
The wireless cutout?
Yeah, it just,
To the drum?
Yeah.
that's why it's kind of stopped.
Like it's gone? Do you want me to try another battery?
Yeah, I would unplug it and plug it back in again.
Cheaper, yes. Reboot the dog. Now with the drum tracks, red. Okay. Oh, here we had it. Yeah. It's easily used. Put it that way. How is that? It's just easily used.
Better?
It's good now. Friendly dog. That part we had. The track is now it's keeping a distance. All right, that looks a little better. Oh. Yeah. Okay. Okay. So you want start it up. Oh yeah. Okay. So for the second piece, we're going to demonstrate a little more of the kind of voice commands, and hopefully, what you're going to see is that as Jonathan whistles, he's got a different pitch, and it'll move forward, backwards. What do you also have? Up and down? I don't remember what you had.
I'm trying any direction you want. So I'll go left, right, forward, back.
Well, just you pick it.
Yeah.
Okay. So as he whistles, it'll listen, and then send the drum bands to.
I think it was colder yesterday, but it feels colder today.
It was definitely cool yesterday.
I'm overdressed.
I'll switch with you. I'll go to Florida. Actually, I don't think I can.
The humidity just kills you.
Yeah, I would be a warm desert climate.
I'd rather be cold than warm. Because when it gets cold, you can put more clothes on. But when it gets warm, you can only take so many out. Alright. It gets really cold. So he's controlling the drone with different tones of a whistle.
I know. Yeah. Should have brought a water bottle. I know.
We don't know if it was right or not.
That's the presentation. Any other questions on what we had it doing?
How we did it.
Yeah, how we did it. Everything's code controlled.
So I tested it.
Yeah.
Lots.
Try it out.
Yeah. When you were with her,
Someone over there?
Yeah, there'd be two things. We saw a piece a couple of months ago where they were playing, blind folks were playing baseball, and there's a ball that beeps, and they learn real quick, and there's beeping bases. As soon as they hit the bases start to beep, and they have to run. So it's the same concept. You have facing forward camera, rear, because it's got to watch where the person's going, right? Can't drive them into traffic or something. So the forward-facing camera's going to be watching what's in front, like the cane would, backward-facing to make sure that the person's still there, and then there'd be some type of audible beep coming out of the drone, whatever, we'd have to test out what would work well, and they would just assume.
Or even some kind of like haptic feedback on your computer. Like next to your driving. So there's lots of fun. I kind of wanted to save most of it and grab certain levels. It actually implements facial recognition. Red face and the combination of that. So, one person.
How would you deal with, like you said, zip on my shirt? Now you've got, you got the facial recognition. You got a crowd of people. I mean, look right over here. How's it going to find that versus 5 black cones that are over?
Right.
Better software.
Yeah, software on board. The other thing is, if anybody's been skiing and they see a blind person skiing, they wear something that lets everybody know. So probably would get some type of vest that the person would wear that is very easy to track, that wouldn't get confused, that wouldn't confuse the drone. So it would be, have to investigate what's best to do, press and something.
Yeah, or especially some kind of like some other kind of tracker, like RFID kind of thing. Something where it's not necessarily just visual.
Yeah, you don't want two people are together. We don't want to keep
Exactly, like a unique chip or something like that. That way the visuals just kind of augments the already built in.
That would also get rid of some illusion, right?
Right, exactly.
So if somebody cut between you and the drone,
Exactly.
Precisely.
Right.
Precisely.
That was like the QRC code. That gets hidden and the drone gets lost.
Right.
I'm going to be your taskmaster next.
Thank
Thank you very much.
Thank you.
you.
All right, Mike, you ready? All right. So they all doing the same thing? All different.
This is the creative portion. This is the creative portion.
The speaking part on the way first. Hey, yes, it turned out well. All right, guys. All right. I currently work on the Endure system, which is a reporting system for unclassified information sharing between U.S. military forces, post-station forces, law enforcement, and stuff like that. Most recently, I've worked on the mobile Android iOS version of that reporting system. So that one of the cool things about that is that it enables reporting on field instead of having to remember everything in your head and type up a report about what happened when you get back to your office, which may or may not be anywhere close to where you reported your incident. One of the key features is the ability to fill out a report on site. And the app allows you to utilize the device's GPS capabilities to populate geospatial fields. So you can say, I'm here. This is where the report is, and it'll fill it out for you when you submit it. Another capability is allows you to attach media, so you can take a picture on your phone, attach it to the report. Really useful when you're on site, so you don't have to worry about losing it before you get back to your place where you have network capability. However, imagery obtained via mobile device can be limited. Some things like accessibility of the site, visibility, or dangerous conditions on the at the site could prevent you from being able to capture media while you're on the site. Examples of that would maybe there's debris maybe in the way, so you can get close to picture something, or maybe there's a possible explosive, and you definitely don't want to send people in to capture pictures of that. So this is a perfect opportunity for aerial technology to be able to go in and capture media for a report location. So if someone reports an incident, it'd be very useful if they are unable to obtain imagery from that to be able to maybe send a drone in. Other use cases for mobile or for using the drone for reporting locations that have been reported but haven't had any updates. So if you go out and do some kind of image capture and figure out if additional action or follow-up needs to be required for that particular site. So for the portion of this hackathon, we opted to utilize the autonomous flight camera and networking capabilities of the drone to integrate the media capture system with the current mobile application. We developed a stub implementation of the current Endure mobile gateway, which is the service that the application interacts with to submit reports and query for updates. We also we updated the current build of the app to be able to communicate with that server. And we also developed a drone management service that provides a RESTful web interface for communicating with the drone to execute waypoints, including navigation and image capture. Also, we found it useful, and as many of you probably did while we were doing development, if we weren't able to work with the drone, we found it useful. We built a stub client that mimics a lot of the API that the client provides. When you're actually interacting with the drone, so we can do the GPS and mapping and run everything without actually having to have the drone. And we're hopefully maybe considering opening sourcing that for the community, so that if you can test things out before you even have to go out and use the drone, so you can make sure it doesn't go fly off in the building, or you actually have to work on it. So we developed a series of waypoint commands. So the command takeoff, landing, moving set of coordinates, changing altitude, capturing video, capturing pictures, heading towards or turning towards a specific heading, or turning towards a specific set of coordinates. All of these we used yesterday to complete the course. So basically the same. Run the course yesterday is going to be the same thing I'm going to demo today. By splitting these capabilities into discrete commands, we're able to run accomplish essentially any pattern we want. And we used it yesterday, and we're using it today. So then after we developed those two services, we integrated those together so that when a report is submitted via the mobile application to the your server, the drone is going to go to that location, the report is submitted, start executing the search pattern. While it's doing that, tight spiral that's kind of fanning out, it's going to be doing some image detection, image processing to look for a specific color. In this case, it happens to be a rather threatening, formerly inflated children's playground object, which hopefully, I know Wes told us that the tape was going to be orange, so hopefully the color similarities here aren't going to be too crazy. So I'm going to go ahead and get set up, and we'll demo the submission of a report and sending the drone to capture pictures from there. Any questions so far?
This thing says 2 minutes left and they have.
Anybody use the tape? Yeah, do any of the team need this tape? Oh, better to.
Battery is not ready.
I also don't know if anyone else realized that next time they change their password, their domain password, is something you can type in with one hand while you're on your laptop outside.
That number keeps going down. Oh, is that the video from today?
It was nice. 32 gigs.
Yeah, now we got 7 hours.
Oh, there we go.
Oh my God.
Might be too late.
Ah!
Got one here. I think it should be good. All right.
I got Tim's
Helping
face.
the enemy.
Absolutely. Thanks, though, Tim.
Oh, no problem.
After what we did, we owe everybody.
You stood up. You know where one of my clothes? And And you have
All right, I've almost got everything networked up here. Forgot that I had to sign in. We're using the network on the drone, so that's why it was took me a second. Okay.
I think I'm just gonna sit down.
There we go.
That's my knees. It's trash.
All right, I should be all connected. I have pre-populated a report with a location somewhere thereabouts based on the performance from the GPS yesterday. All right, just learn a quick calibrate real quick. That seems to help with the accuracy on the GPS. Right, double check the direction. East. West. That's right. That's west, right? That's good. Okay. All right. Another big part of what we developed was we got a web UI that reports the GPS accuracy, the current position of the drone, as well as a compass heading and an estimated speed, as long as a map which that displays the waypoints as it flies, that you can keep track of the drone as it's going through the course. The camera, the current feed by the camera, and I'm going to bring that over to the judges while it's running, so you can see that in action. So I've got the report up on my phone with the pre-populated location over thereabouts. This is existing. Your mobile application is part of the process itself, but this is just the existing app. I'm going to take it off. All right, so I've got this is the. So I'm going to publish the report to Endure. It's now taking off here on the web, and it's going to draw a line to where it thinks it needs to go, which doesn't look anywhere near what it needs to go. Run. Oh.
How we not lost the drone past that fence? I thought we'd lose at least 5 drones at that. At least.
You only lost one yesterday, right? We went
We didn't really lose anything.
back and scratch.
Yeah, through the wall.
Yeah.
Take 2.
All right, because I don't want to run the risk of it flying away because of the GPS inaccuracies, I'm just going to real quick demonstrate the search portion. So what I was trying to do was go fly to the report location as submitted by the device.
So there was, yeah.
It's interesting though.
Yeah.
You good?
Right, to break the sheet.
All right, so instead of having it fly to the report location, which could be anywhere, I'm going to have it just execute keep the search portion, detect an image, and I'll show you that image that it detects. It's going to take off, and it's going to start doing, it's going to go a little bit higher, so you can get a better picture of the bottom. Just appears you have a little trouble getting up there. Well, it's about half a meter short of where it should be, so I'm going to make it so it doesn't go quite as high, so we can see everything going.
It's just his drones are so lightweight. It's just getting.
Yeah. And the motors aren't strong. There's very little strong. I think the battery, like, offset like that.
All right, we're going to try that again. And it's very easy for me to just change those parameters. So it's all just sending orders to that one waypoint endpoint on the server. So it's going to take off, hang out for a little bit, go to a height of 1 meter. Not quite as high. You would think Monday would have been the day that it would have a hard time. All right, so now it is executing the first pattern. And I'm going to throw this over there. Okay, so it stopped and took down. So it's pre-programmed to find that color right there. But we could update the search routine to maybe search for metallic objects or something like that, which would be useful, and potentially capture multiple, a series of images rather than just so the image that it detected is that. So you can see the green ball up in the corner there that tripped off the image detection. So normally what it would do if you weren't worried about the GPS is it would post that media image back to the indoor service, and you could then would be able to via the mobile app, you can actually go and search for that report, and you'll be able to see that picture. And you go in and zoom in and pan it around and look around. So it's all integrated together, and it works great when GPS is great.
Awesome.
So that's it.
All right.
Questions? Thanks.
All right, Whirly Bird.
It's a real pity Wes wasn't here. We were going to try and get him to wear this.
Sure, that's it.
Yeah, it took off.
Huh? One more. You up? Yep.
Right? We need 3 volunteers.
Tiffany.
I can't. Can I do it while I'm filming? If you'd like. That would kind of be interesting.
Go for it.
All right. Good. All right. Where do you want to place them? Where do you guys want to stand? You can
Okay,
I
so-
get your extra drone if you want.
Okay, so software is not viable unless it's flexible. We had planned on doing an indoor presentation first, defining the mission in there with volunteers, and then coming out here to present it. Instead, we're going to do it backwards. So we have a UI portion. We'll show that later. But right now, we need three volunteers. Come on. 3 volunteers who aren't scared of a drone. Come on.
Tiffany.
Oh, okay.
Tiffany.
He's going to represent the picture taken. What's the picture taken?
Not me.
Picture. Video. What's the video? Video. And you're going to be on land.
Excellent.
Okay? On land. So that's where the mission's going to end. And who wants to see the first location? First. So the mission will be go to him, take a picture,
Go to you, wherever you want to go. I don't care. Well, face out. Just go down a little bit. We're going to program it to tell what to do. Yeah. So where do you want to land? Where do you want to start? Here someplace? All right. So what we're going to do, you can look up my shoulder if you want. Look that out.
Picture video. So we're taking a picture of this guy, video of that guy, and landing on him. Let's see.
Take off there. Picture, calibrate there. Take video, calibrate. Just there and land. Okay. So look out. Okay, so now you try to find the second point.
scoring for a touchdown. So hanging in there. No, it's just the GPS.
Okay. Oh! Take off that hole. I don't know. Maybe take off the hole. I don't know. It kind of protects it. I don't know. It's up to you.
Oh, well, yeah,
Yeah.
we wanted to keep the hole on for protection.
Yeah, makes sense.
The problem was it was approaching this position too fast.
Yeah. All right.
Can you fix it, Doc? Oh, yeah, I got the tape for it. Sorry about that. Sorry about that.
Oh, no, you're fine, you're fine.
It was approaching your position, it's just too fast.
Yeah, I gotcha. We've had plenty of this.
Yeah, we'll just take that.
In space cadet, swords ever show up?
It's good.
Don't mind if I do.
All right.
Yeah, the machine's gonna be out here somewhere, but we kind of don't know.
All right. We'll continue this on the inside.
Hold on.
Anybody leave a backpack out in the parking lot? I think that might be Mike's.
It looks like backpack and brought it in.
You want to show them why.
Okay.
That was on.
You want us to finish right now?
So we heard Space Cadets. Did you guys show up? I don't see them. All right, so we're going to go. We're going to let Whirlybird finish theirs, and then start with no comment as the first inside one. Then do roller coasters, and the Temps, the Narwhal Vengeance, and Space Cadets if they show. They said, keep
I want that at home all the time. I'm like working, but I feel like that's not. At night, though, like 55.
So what are we going to There they are. One.
Oh, no.
Space Cadets.
I understand. Once we went outside.
Whoever brought this in,
Yeah, really. With costumes like this?
I think we can rate it 1 out of 10.
We're ready to go then? Yeah.
One conferencing service. You are joining your conference room. You are the host. Access is immediate. For a menu of available prompts, press the star key, 6, and the pound key.
Sorry about that.
Do you want to mute dial-ins and stuff like
Yeah,
that?
how do you hang up? How do you get rid of the doorbell?
Doorbell star 47 pound.
Invalid entry.
Star 47.
Invalid entry.
Anyone else know how to do doorbells?
Asterisk 47. I'm just kidding.
If that doesn't work, flat.
Invalid entry.
We'll deal with it.
47 hashtag.
All right, let's go.
Okay, as we started outdoors, we just wanted to give a little better overview of what our effort was and then show you the UI that we had created the mission with for outdoors. Okay, so 2 main parts to our effort, and the first was to create a mission API using some of the automation libraries already available for the AR drone. So we created, or Dusty created as our main backend developer, created a high-level API to approximately 11 different commands, right? Rotate, move to coordinate, what am I missing? Take pictures, video, calibrate, a whole bunch of other stuff. Yeah, exactly. And I was handling front-end things, and our more creative portion then, in addition to the backend, was to integrate with Cesium. It's like an open source Google Earth mapping plugin. JavaScript library. So we brought those 2 things together. Probably can't see this, but this is just kind of laying out how we think the judges should score. They can review that. We make sure they have a hard copy of that. Yeah. But yesterday on the mandatory portion, we hit all the targets. We overshot the landing zone just a little bit and landed. Actually, you only supposed to go 8, right? So we're good. Yeah, but I'm going to do that at the interim landing. Okay, at the crosshairs. So we overshot that a little bit. video, it did take video, it did take a picture, though not of what you were up to take a picture of. So we did pretty good. Now, the things I just wanted to highlight about what the API is that it's modular and it's composable, so we could go outdoors and create any mission we wanted to. This is a simple example of the high-level code, all the high-level code that was used to execute the mission yesterday. And most of this is initialization, here down, just variables. The main part of the code starts right about here. And this defines about 10 different steps. And you kick off the mission. And then it executes the whole thing, I promise. Just give it a hands off. And then the UI, and maybe I can bring this up on. There it is. This is Cesium in the background for the log mapping application. Three-dimensional. And you pick up points. That's what we were doing out there. When the different folks went to the different locations, simply double click where they were standing. And that puts in a loop to event. This is basically the mission that we executed. After doing all those different steps, so start mission and it kicks off. And then you can come back in here and start making changes to it. So we could go adding new loop 2 locations. Come in here and at the different locations we went to, just tell us to do maybe more than one thing. So that's really the flexibility of our solution and how we went about it.
It's similar to kind of ground control and some of the other similar to that, although it's more geared toward this particular. The other ones were here. Set waypoints to go through, maybe a little more. That was kind of it. This one, you can set waypoints, you can self-hover, you can self-land, you can get back up again, all autonomously, take pictures, or specify time frame, starting video, going through more steps, stopping video, doing a whole bunch of other things. But that's what the underlying API and the UI allows.
So I guess at that point, we'll just wrap it up. Take any questions.
Does it still run from your laptop, or does it actually upload?
It runs from the laptop. The laptop has to issue commands. You don't have anything like that. Anyway, I think that's about it. Unless you want to go into the details of all the steps happen, all the little things. There are a lot of little things in how you configure the missions and how long the mission do you want to run before it stops. How often do you want it to update, like a quarter of a second? What your tolerance is when you hit a point, like you're within like 0.0001 of the points that you have considered there, you want to make step, etc. A lot of that stuff's configured.
Okay. It's my colleague, Cabrera. We're missing 2 people, George Turner and Ben Buncombe. They're across the road, looking to have a way of open rock. Set up there, we've got a video here. Evan, you there?
Yeah, can you hear me?
We can hear you loud and clear. I'm going to cut the audio again until we get started with your portion. Okay, could you, let me get video. So as you can see, we tried to lengthen the range a little bit. What we can do with this. I bet every one of the teams here, when you first got your drone, you said, okay, so what can I do? What are the limits of what it can do? What are the various things that you take it out apart? Just like we saw today, you get these flyaways. Well, our first experience was, hey, we've got an API. Let's do up 10. And we watch the drone going up. Okay, I think that's 10 meters. And it keeps going up. Is it really 10 meters? Oh, no, the API says up speed 10. You know, and by then it's way up there. And we're putting in the land commands, and the wind is catching it, and it's going off. And so we're chasing after it across the park. It's up above the trees. It's going into the residential area. We can be hopping fences and dodging dogs to try to figure out where this thing lands. We finally got back into range. So I started thinking, I wish we could extend the range. There are a lot of solutions out there. I think Marcus has talked about some of them, Wi-Fi repeaters and powerful routers and directional antennas and that kind of thing. Our solution wasn't to take the Wi-Fi cloud that connects the controlling device in the drone and grow it. Instead, we thought, let's take the controlling device and marry it up with the drone. So here's what we came up with. Let's scroll up. The top left, drone plus phone, strap them together. Always remain in Wi-Fi range. Okay? We control the drone through an Android app on the phone. We control the drone through an Android app on the phone, relaying commands that come from a web server that also serves up a client interface. That goes over the public internet, hooks to the phone over the LTE cloud, and into the drone phone pair. Questions so far? Okay, let's put audio on these guys. Now, as we get going, yeah. And we noticed Amazon has some job recs they're advertising for drone pilots, which would probably have to do some kind of instrumentation only flying, which is one of the challenges we've had. Anyway, we tested this with a phone strapped to it, up, down, move around, bubble wrap on the phone, that kind of thing. We have run a test 10 miles away, controlling the phone. Theoretical limits, somewhere around 24,450 miles, which is half the circumference of here. That's how we came up with that one. Anyway, Evan, you're out there? George, you're out there? Yep. Do we have things configured?
We are ready to start. So we're gonna have two video feeds here. The video feed on the right is we have been doing a Google Hangout. So he's recording the action from his phone. So that's the Google Hangout. And then the video feed on the left is the video that the drone is actually outputting. So we were able to capture the video feed over that 4G connection. So that's what we're going to be seeing, the dual video action. So here goes nothing. I'm going to skip the initialize button. We hooked up all the comm links before we started the presentation. The initialize button is what initializes the connection with the drone. So I'm going to skip that, and I'm just going to do the takeoff. And okay. Yep. Kind of. All right. I'm going to pick it up a little. All right. I'm just going to do some basic stuff. There are buttons on the left that do some basic operations. We have a drop down here that has pretty much anything you can do, but really the main way to control this thing is with a keyboard. So for like any gamers out there, it'll be like the arrow
WS, AB, right? So WS to go forward and back, A and D to spin clockwise and counterclockwise, and then up and down goes vertical, and then left and right goes directionally left and right. So I'm just gonna move it around a little bit. Do some spin action. Buffalo one.
If you turn to the right, you'll be seeing George.
Okay.
We're avoiding that.
Yeah, I was avoiding that, but there's
Okay.
okay. What I really wanted to do was invite any of the judges that want to pilot today to go ahead and come on here and pilot it, and I'll walk you through it. This is an opportunity of a lifetime. Amazon is putting out bomb racks that require 5 years of drone piloting experience to be able to even fly for that rack. I'm giving you the opportunity to build your
We're just
skill
trying to
set
get your attention.
long distance.
We got some wind out there.
Nobody wants me to do it.
We're going forward.
Okay.
Yeah, I did mention the range, 24,000 miles.
Go forward.
That's theoretical. The effective range is battery life.
You go, I'll tell you.
How much does the added weight of the
Go up, go up, go up.
We haven't tested enough to know, honestly. It clearly is a problem. It gets altitude challenge and stability challenge.
You can go forward. You got room. You can follow George.
All right, so
Keep going.
invitation's open.
I'm thinking if it's like a video game or future ISS are back here, should try.
I do think you should be, realize we don't know what's out there. There's wind. If you just go charging, you could be over a ravine and you could lose it. So be careful.
Yeah, you're good. You got distance, so you can keep going.
So who's up?
How do you step up and try?
All right. So
Okay.
he's gonna control it. So you guys can
Give a little tap.
As long as Tim here, as long as Tim here is not flying, we're good.
Hi.
We wanted to do this at Garden of the Gods. They won't let us fly a drone there. Too many climbers get buzzed. But I think theoretically we're not supposed to fly very good. It's fun.
all right.
But they don't have range. With our department.
We have Parker controlling the drone. He's just doing a few forward movements.
Go for it. You want George to get down there?
Sure. When you just go forward, does it just move forward a little bit, or is it like a set amount, or does
It sets the forward command that stays. Basically, the way that the drone is controlled.
Climbing altitude.
Altitude. All right.
stop receiving?
So to answer your question, when you send the drone a forward command, it keeps going forward until you tell it to stop. So what we have is on key down, we send the forward command. We'll keep going forward, and on key up, we have the cover.
Do you have any of the telemetry that, like, these haven't tell you that you're getting close to the ground? Do you have anything that you'd be able to pop up that would tell you your altitude is 1 meter?
We weren't able to plug that in yet.
I mean, the best we have is video.
Right.
Kind of tell.
Are you able to switch modes on camera to down camera?
No, with this interface. We had it going with another one, but our challenges were huge trying to plumb our way through the networks.
Right.
We had network address translation firewalls. We had issues of trying to, at first we thought, okay, how do we get pinholes through them?
Somewhere in that shot,
Try VPNs. Eventually what we came up with was, and the phone getting LTE and Wi-Fi going at the same time, really hard. We tried rooting it, we tried different, all kinds of things. We did is put it in hotspot. Okay. It may be. Shall we move into technical end? So I was talking some about the challenges we faced. At first, I thought, okay.
You can try the reset.
Oh, okay.
Want to try again?
I want to try one more thing. So we crash landed. I'm going to try and do an emergency reset here.
Okay. Ryan, find some more. Heidi?
All right, I'm going to land it, guys.
Go for it.
Hi. First charge.
Okay, you got that out. Could you move to the obstacle section of stuff from here?
Andrew, we're gonna come back now.
Sounds good. I can figure out how to get over to that monitor. Okay, we had three huge obstacles. Getting Wi-Fi and LTE to go simultaneously. We tried VPNs, we had some that worked, but you couldn't figure out the IP address of what was on the other side because we had these network address translation firewalls and other things like that. We tried connecting this way, we tried all kinds of things. Forwarding was not an issue because we don't control the T-Mobile routers, stuff like that. What we finally ended up with was, A, you put the phone in hotspot mode. That activates both radios. B, we direct connect over SSH to the drone, and we found you can send DHCP connection commands, and instead of having the phone connect to the drone, you tell the drone connect to the phone. You then inspect the connection routing tables to figure out the IP address based on MACs, things like that. That gives us, we took the hack in Hackathon very literally here. That gives us the ability to figure out how to talk to it from there on out. The next thing, okay, so the next problem, okay, Wi-Fi, LTE radios, IP tunneling. The last one was much easier, and that was to get the command stream going in and the outbound video and informational data going back out for the UI. But those are the big challenges we attacked. We had code on the phone, an Android app. We had a front end written in Angular, JavaScript, etc. We had scripts, commands, and code for the drone to get in and hijack the Wi-Fi connection. And then we had, I know there were 4. Oh, we had the server stuff that had to relay the commands and service the video and do some of the encoding. Some of that. Questions?
What phone did you use? How heavy is it? Yeah, how did that?
It's bad. We've tried to go with my son's phone. He's got a really old one, definitely very light. SIM card incompatibilities killed that. That would have been the lightest. The best one was Sean's phone. It's new, very expensive.
It's a Samsung Galaxy S9.
And that's what we used to test out, wire it on, bubble wrap it, figure out that this works. The one we want to use is an old generation Nexus 4. And that made it very, very hard. Very, very hard, which is why in this demo it wasn't strapped on.
Now, did you like balance? How did you?
There were balance issues, there were center of gravity issues. We just put it as centered and low as we could get it.
Okay. And the gyro stuff.
They struggle at first. When it works, once the takeoff goes, and then it would stabilize. And it was more or less okay. But yeah, was crazy. And you saw yesterday, you can send a drone a command and it'll fall on its head. We had that happen. We narrowed it down. I'm commenting out code. You know, what is making this thing click? The hover command was poof. We didn't want that happening. We also don't know what's going on up there with wind, so we didn't risk the phone.
What was your guys' video though? We actually implemented this kind of thing with the 4-year memory. So the Raspberry Pi is kind of an access point. But we ended up finding out that there's too much video device to process.
You can probably talk about that.
I didn't see much delay. I mean, I just
Was that a
saw
light
it.
video?
It was choppy.
It was delayed at first, and then it kind of caught up.
Yeah.
And I think we were like doing 10 frames a second kind of thing. It was pretty low frame rate.
Gotcha.
Okay. I think we need to press on, please. River coasters is up next.
I want you to connect your demo. You're part of this board. Somebody using this? I want a flash. We're gonna land. You might notice that those jars and stuff got moved. No.
Hi, we're the roller coasters.
Alan, Brian, me, and my son Parker.
We started out trying to
We're going to just talk about not just the creative part that we're going to do in demo at the end. We wanted to talk a little bit about just the whole process. We had some initial, well, anyway, I'm going to go fast. This is what we're going to cover. So our first thing was to have fun and let the boys fly the thing and code. My son is in 8th grade. Brian's a freshman. Brian's got some coding experience already. My son had almost none. So it ended up being my son just flying and blowing it off a little bit. So
not here, I can talk about it. Our initial first idea was to chase a laser. We recently got cats in our house, and so I've been playing with my cats and having it chase a laser. So we're trying to turn the drone into a cat. And then when we had the initial, when we kind of were getting together, the obstacle course was, a lot. We were just thinking, hey, are we going to fly? What's this going to be about? So we were really kind of on Wes. Hey, do we have a definition of what this thing is? So that's one of the really early things we were learning. So first flight's like everybody was in this conference room. That was, and then Brian took it home and did backflips with it. I don't know how many got to do that. That was a lot of fun. And Brian ended up building in the first week a very stable, good control system for us that just stayed hovered really nice. We got forward, back, ASWD kind of stuff, and we started trying to do obstacle courses that we were making up in our driveways and stuff and crashing up everybody. And Parker and I were focusing on the chasing the laser piece. It was a really nice thing because they had the drone. I would just use the web client or just the video on my laptop to just kind of chase a laser, and it was easy to develop code independently. And that's very early. So there's a picture of me looking at my computer with a laser going backwards, trying to figure out, all right, what exactly, how do I identify that little red dot? And I had to deal with, you might notice on the left-hand side, I'm by a door, and it's going outside, and there's this big area of white. So that was a lot of interference, and I ended up going down to a white wall that made a little bit more stable and noise, a lot less noise to be able to try and do that. We started out with the YA drone module that we got off the internet, and we adapted it and moved to our initial takeoff, going forward, landing, that kind of stuff. Like I said, Brian's code, we changed the speed. When we first got it, what was the initial speed, do you remember? It was like 25. When we put it up to 75, suddenly we could really control this thing. It made it a lot easier. And our first Monday after we had gotten it, we had this control program, and I said, hey, we need to switch cameras. And so he just coded it in 5 minutes, boom, and we had this great way to switch between cameras. And we were off and rolling. It was a lot of fun. So this is not showing up well. I apologize. I took some filtering kind of stuff. We were going to use OpenCV at first, and that really didn't seem to be as friendly and as fast as we were hoping. So all I did was just take RGB filtering, looking for only the red, taking all the white out, and I ended up with taking a picture of, like, we were going to do some formation flying eventually. If we were going to be able to track the laser, we could track it on the ground, and then maybe we would be able to track that car. And it didn't have enough red on it, so I put a tomato on it. And the bottom camera just wasn't working for us. So I'm trying to show you that with the filtering, I ended up with a fair amount of large little red areas, and instead of just one big spot. So let's see. The bottom picture, we took the downward camera on one of our Mondays here. There's a little red dot, I guess at 11:30, underneath the shadow, and it just couldn't find it. So we changed our focus to just the front camera and had to, figure out a new way to be able to track the laser like a cat. Additionally, we also didn't have any success finding the laser on asphalt in the daytime. It wasn't really bright with the laser. So we had to come up with some other way to do the obstacle course. And that's when Alan and Brian started talking about doing a recording of a flight. We would fly it manually.
and record it, and then just try to make it redo that over and over again. And that, we ran into some technical problems that we'll talk about. Well, we did some other stuff like a red ball that got pushed around with the wind, and let's see. Because Alan and I went to San Diego last week for a whole week, we had to really kind of finish this up a little while ago. Made some tough choices about how to really, get something that would work. So we didn't consider GPS because of the error that we kept hearing about from all the other people. And that's when we got to the QR code reading. And the trials outside really worked quite well. We ended up with some flimsy cards that were blowing around in the wind, and so we came up with the clipboards that worked out pretty good. And, it just kind of worked out for us to do the QR code reading to navigate. So we ran into some problems with the video and the snapshot challenges. You want to talk about that?
Sure, I can talk a little bit. Part of it was that we were controlling the drone QR codes, and it was in a hand looking for codes and telling it to take a picture. Getting back to that was difficult, so what we did is switching cameras. So QR code would say take a picture, and then the camera would switch to down camera, take that picture, down camera, and go back to the camera. So that was the solution to that. And the same thing was going to happen with the video, although last minute, like, it works 3D live, it doesn't work. That was part of the stuff of that.
We started to really understand that Wes's view of the obstacle course was that, hey, this is a machine. You can actually just tell it what to do, and it'll do it. And we came to realize that it was already a beast. We were trying to make it a cat. Trying to tame this animal was, making us make choices that we weren't really wanting to do.
Kind of how that was our initial idea was we were going to put a QR code in front of it, have the entire flight pattern go to the next QR code on the go. And we backed off on that because of two reasons. One, the QR code wasn't big enough to get all the commands in. And two, it wasn't repeatable. So we decided, well, we'll just kind of interact with it just because it goes through the course what it's all out there.
But Brian saved the day. Like, we're changing code like right before 1 o'clock. He shows us. Yeah, we were working on it for like 20 minutes. He shows up and does it like this. He was our secret weapon.
This just kind of, I think this slide is talking about how we extended the QR codes. Initially, that was our first implementation of the QR code command. Like, oh, crap, we're down the water. Something else, you gotta go down the code. So like, well, we'll extend this to a command file interpretation. So we added that same command processor, just put the file in it.
Do you want to do that now?
Good. Yeah. So let me just pull that back. I'm going to load the command file. I'm just going to do a small little demo. I'm basically going to fly a box to the back of the table. But we might need somebody to stand over there and do something else. So
in case it just runs them up.
Okay. So we're going to kick it off.
We wanted it on the table, but
yeah.
if I pushed it too much up.
So that kind of demos two things. It works and it's not accurate. This morning we ran it, it landed right on the table. Those things slightly different. So the third attempt, which was not 100% complete, was to fly it via the app that Brian built and record everything that you're doing, kind of like record macro. And we did record it, but the playback was not successful. So we did not put that on the course.
code challenges, successes. So that we're going to talk through that. But we did have a couple of problems. The first QR codes that we were putting up there were like, go right. It would just go a bunch because it had reading one, reading again. So that was a fun challenge to get past. We did it with, how did you solve that?
It's all the frames getting captured in the buffer. So every time you did go right, next go right. So what we did is we had a timer, so it wouldn't start reading again until that time had passed. So
It also meant that we weren't in control of it for that period of time. So it was kind of a fun thing.
It's a little bit, but it works.
All right, so the QR code ended up being, it worked pretty well for us. And then we also added a bell so we could tell when we had done it once so that we didn't have to just overrun it. All right, so chasing the laser part. I might talk through this a little bit and then demo it. So the first working versions were just simple left and right, try to alternate. First I had to figure out it was outside the center, and then I would just do a right or a left and an up and a down, and I would alternate those. So the second generation that I built was adding some multiple three-dimensional flight at the same time. That scared me quite a bit because it seemed a lot less stable. And I ran into the same problem that they did with the QR codes, that I would send it with the laser. The laser is still in a certain spot because of latency. And so it would say, go right. And then it would wait. And so it's starting to go right, but the video still says go right, so that it's going right again. And so I had to do some kind of, I had to hover between every single, I had to do a move that was about the size of the screen, and then I had to do a hover for about a half second so that it would clear out and be stable and try it again. So we ended up, well, let me just demo that. Hold on. Oh, that's helpful.
you want the lights on?
I want the lights on. Turn off. That's the trouble, that. You should Yeah, well, that's what I was worried about. The one, I think it'll be okay. Okay, so there you go. There you go. We'll try on the blue screen. So you'll see that I can put the laser over here and adjust the little
doing left and right alternate. Some more. Alright, so now I'm going to land. So the section, I wanted to do that better. So I decided that what I wanted to do was do the angled slope instead of just left and right alternate. So let's give that a try. All right, so we'll go right over here. All right, now I'm going to land. Land. All right. And so that was chasing the laser. We actually got that. But then I started to like really want to see what else I could do. I ended up capturing about a minute or about a second and a half of where the laser was. And so by doing that, I was able to kind of give it some motion. And so I decided that I could send commands to the copter with like arrows or some kind of code. And I decided, so I overthought it and said, oh, I'll do an arrow. And when I was trying to code it, it turned out that the easiest way to go left is to just draw left or right, or up or down. Because I had wanted to like have the drone detect like a counterclockwise or a clockwise thing and make it go up or down when we were originally doing that. So I'm going to try to demo that.
You have any drinks? Hold on to them. Or finish.
All right, so here's like all right, here we go. I'm going to try to capture a left, and I'm going to try and capture a forward, and then a right, or a right, right. Whoa! By doing the minimum boundary rectangles, I was able to say, okay, there's no up or down on the second and a half image. So I don't know if you can see this, but I get this is where it captured the laser when it was a little higher. And so I was doing the beginning and the end, well, the most left, the most right, the most top, and the most bottom, trying to find the deltas. And I could say, okay, horizontal line, and then the beginning with the index of the array, hey, which way did it go, back and forth. It ended up being super easy. All of a sudden I was thinking, oh, that's how they do like pattern recognition for, you know, letters and that kind of stuff. So I had a lot of fun just doing that kind of work. Sorry it didn't, you know, turn out great, but that's pretty much the presentation. All right, all right. The summary is that we ended up having a lot of fun making friends. All right, next up is Jess with the films.
No, she. Welcome to the meeting.
I'm just wondering if you want to follow along, if there's anything you want to interject. Feel free. Yeah, we'll relay it. Okay. All right. So here we go. Hi, we're the professionals in 15 magical programs. I can't remember that, but I can remember PIMS. So, and our team is Dan Beatty, Brian Schill, Tim Mitchell, Richard Dorsch, all out in our Alexandria office, and I'm kind of their mascot, and their Springs representative, button pusher, drone picker upper, drone, pick up pieces, reassemble, stuff like that. And our concept was pretty much definitely was driven heavily with Dan's description here of I love how he says it's pimping ain't easy. Neither is finding an empty parking space. Circling, watching, find a spot, blah blah blah. And we actually witnessed this. I went out to DC with my girlfriend Bonnie last week doing some touristing, watching those guys hacked. So, yeah, several parking lots out there. We don't have parking phones. They have parking phones. So, I can relate to that. And one of the things that Dan was talking about was, hey, let's have our goal use a drone to fly parking lots, identify where the spots are. And a variation of that too was we could get to was just the button that takes off and goes down. That would have been really cool. But, so anyway, general design is a single drone or a fleet of drones. Looking at various parking spots using OpenCV or count pixels, colors, stuff. And sending that back via our program that's controlling the drone, putting images in the database, doing image processing on them, and serving those up to our parking app. That's a design concept. So we basically have using MongoDB. We are heavily dependent on played around and experimented with a lot of API
even though they're a little, there's some nuance. All the, hey, what's the best way to get from here to there? Stuff like that. So, on the surface, you see those APIs and you're like, oh man, we can just, oh my god, this is amazing. And then, okay, it's a little, you know, drill into that problem a little more. It's not as easy. We play with a lot of that stuff, but what we really gravitated to, hey, let's use GPS. Specify routes, parking routes. That's kind of what we gravitated to. But and as you know, unfortunately, that's like the weakest piece of GPS, locational accuracy. Kind of blows that whole concept out of the water. Unfortunately, we didn't really find that out ourselves until very late in the game. So what happened is became so dependent on that, so dependent on this Avalon protocol that really it hindered our ability to do a lot of other things with via the other APIs, like taking pictures, switching cameras, stuff like that, because we were so heavily dependent on the Avalon stuff. The easiest way for me to describe it is that once you start using Avalon, it like takes over. At least our experience was, we haven't cracked that nut. It keeps you using some of the other issue commands all day long. Just ignores it. Whenever Avalon has like native primacy over drones and other stuff. Anyway, so that was our approach there. We started out using YA drone, but there were a lot of conflicts there. We never quite got that working correctly with Matlink. But we found that the Node.js stuff worked, so we started using the Node.js stuff. Let's see, a lot of problems with, here again, Matlink and controlling cameras and switching cameras and stuff. Notwithstanding the Wi-Fi stuff where, hey, and this is just, this is just grasping the straws on my part. See the link go up and down Wi-Fi wise. Just, I think maybe that's why occasionally you just have your drone doing some hidden waypoints. Wait, easy on. Why not? Never. So, let's see. So, image processing. This is something that Ron Shield did a lot of work with. We took some representative pictures of parking spots, open, not open, shadows, stuff like that, and just went through and tried to understand what was like the same functionality, stuff like that. Where here again, you either go do some of that stuff, just run your pixel counting routines yourself, and get close to some of that stuff. So this was our little part of the ISS parking lot that we decided we were going to use for our that's the one. And I went this morning and basically walked that course from Rotheltopter guys. We saw that you guys went and did that with your drones. Like, hey, if the drone thinks it's there, hey, I'll just go and shoot that course with the drone. We walked every spot for a better mission that way. In the hopes of getting closer to good control over the top of parking spots to where if we were to go further and get further with the cameras looking down and doing our image processing, that would have worked better. But unfortunately, when I reran that mission, it was instead of flying around here. Yesterday, when we were flying our course with the course west of that, we were kind of to the north. The error was about 30, 40 feet north of where it was. And today, when I shot this course and ran it, the error was to the south and it was flying around over these parking spots. So there's no, I have no idea. So, and we had a RESTful service that served up our parking lot database and the AngularJS web app that kind of, hey, pull it up and you can see which spaces and go. That was really fun. Oh yeah, issues, broken helicopters and stuff, broken drones. Just one night, we were out here, and the Roffeltopter guys were out there testing theirs, and luckily they were because Bonnie and I came out and started flying the mission. Our copter flew right over the all the cooling. They wanted to fly in there. And a couple of guys were knocking it out of the way, knocking it out of the sky. And, otherwise, it might have flown off to Timbuktu, so that was good. But after coming back, tweaking code, playing around a little bit more, we came back and just had this spectacular crash right into the thing. I kind of found most of the pieces. So without further ado, we stayed up west. I was really worried about crashing his. That's his drone. Luckily, that didn't quite happen. As after what we did notice is that a lot of the Dan Beatty really got conservative with some of the flight settings that you can set with AR drone phone app. So we just dialed down a lot of the rates, maps, all that kind of stuff. So that seemed to make it a little less catastrophic than issues. Here again, I really already talked about it. We kind of became very dependent on that one. That causes problems with all of them. Our way forward, develop a robust and reliable software library. That's good. Sorry, don't be slow. Yes, I agree with that. Very hardly. Basically, look at figuring out a way to vacuum this navlink stuff. As good as it works for hitting waypoints, it doesn't matter because you have to rely on GPS. I suspect it's got some old electronics. I do Arduino stuff, and I've got GPS receivers, and those are pretty good. I would like to test it. These are so bad. I think you get a lot closer. You can just another light going on there with a light. And use that as your source of navigation. software can be modified to work with existing parking lot security cameras. You know where they are, you know where your parking lot is. The finger in the truck. But a tethered aerostat, that'll keep that thing flying away and losing its mind. Well, if it does, at least it can't be getting further unless it breaks the tether. And then use the forward cameras for swarm-based security monitoring, or just fear monitoring, I like to call that. Yeah, that's what I've got. If you guys have any, I did take a video of just more drone idiocy of trying to get rid of that. I'll put that so, Dan, you got anything else you'd like to add? Okay. So that's it. Questions?
So the same thing as the parking lot, image processing thing. One of the things that always happens around Christmas, where you have parking.
Oh yeah.
Right. So if you have, there are image searching algorithms available where if you have a photo of your car, dump it in, it'll find the video segment that has it. Right. So for 99 cents, you say, "Where's my car?" Right. Send a picture of the car, and you say it's one of these.
Nice.
So that would be something. Not only where can I park my car, but where did I?
Well, if you could just have your belt-mounted drone, and just
I mean, for people who don't have.
Well, that's true too. Yeah. Still, I like the whole. I got this drone, and I'm going to use it. I can't figure out what for. I'm going to use it.
Yeah, that one is
link it out there. What?
The drones in the ball.
Yeah.
Go out there, let it roll around, fly around.
Have you guys, by the way, have you guys seen the kind of second or nth generation AR drone stuff with the little rolly thing? All that stuff, right? And the intrusive. Not that we don't have it, but I know lots more. Great, thanks you guys. Thanks, Dan.
Our wall of vengeance. We will wrap up with the space today.
You want to say on?
Our wall of vengeance.
Hang on.
Oh yeah. Holds in the excitement, everyone. Awesome. That's right.
That's fine.
It's coming out on next foot. Little stand up. That's a production, but I have it on Netflix. It wasn't.
It'll be on iTunes.
Yeah, my stand ups. Those were all on Netflix. Yeah. Yeah.
Okay. All right, so my name's Tim Durbin. If you haven't met me, I was with Narwhal and just had our team. We had Tiffany, we had Mike Jack, we had Tim Porter, and Doug Allison over there. So I'm going to talk about kind of maximizing drone-derived intelligence. What's all the stuff that's coming off the drone? What can we do? Quite honestly, we had a lot of fun with this drone, but it actually is a toy. So we weren't really super keen on spending a lot of time building something that only works with a toy. And you know, the little things in the videos we saw where they could control it and do this and do that and go around and all these kinds of things with control it. We're really interested in the big picture. All of the drones that are out there, the entire spectrum, going up in the DoD from the global hawk on down to the tactical level, and then getting down to the microdrones. What are the big questions facing the DoD and soldiers out there when it comes to all of these different drones? So we were looking at a lot of the fundamental issues they have with this. We started looking for some potential solutions or things that they might be able to, or actually ISS could start working on that might fit in to this whole picture. So what are the really big issues they're having with drones? First of all, just how do you deal with that much data? There is so much data coming in from all of these different platforms, and it's really impossible to view all of it or even know that it exists. You know, us that work with Signy, how many times did something happen and you wonder, hey, I wonder if we go back in time and see if there was any footage or anything grabbed from this time frame. It's quite possible there's drone missions going on all over the place, but very few people know about it. It's nothing that's indexed, it's searchable, you go out and find it. And it's quite possible even footage that was taken years ago could become invaluable if you could find it. So we're kind of curious on how to deal with that. And then once you have all of this data, how do you make it usable to as many people as possible, not just one analyst looking at the footage, but how do they take that and make it so that it's usable by others? You know, there's a lot been put into being able to automatically extract information, and that's good, but ultimately, the best intelligence is going to come from somebody who's actually looking at the footage and can put something together in an intelligence report. Now, the automation might be good at identifying areas that should be looked at, but we're kind of interested in once they do that, I can write something up and make it searchable for other people. And then tactical exploitation. You know, at kind of, you know, the tool level and even at the company level, how can you take some drones and start making it really work for them in a tactical setting? And then some virtual situational awareness. How can we take the products that are coming from the drone and make them just a little bit better and a little bit more useful? So we'll start with the really large data. So fundamentally, we need to be able to index it so that we can find it, make it usable. Very simple. So how are we going to go about doing that? We're going to use Topic Builder to kind of demonstrate with our AR drone how the footage and the information that was gathered from that can be put into a system so that other people can find it and make it usable. So I'm going to switch over here real quick. Hopefully, smoothly. I have Topic Builder up. Log in. So one thing that we did do programmatically in the AR drone is we wanted to be able to, when it's going out there flying, to be able to take images and geotag those images. So you get the GPS position, and you get the image, and you get the orientation. So as you're flying around, you can be grabbing those things, and then you can look at those individual images, or an analyst can be looking at a whole segment of MPEGs, and then they can go in and look at very specific sections, and then extract that through a report. So as an example,
if I go in here and I will do a search for ISS, and I have one intelligent summer solution observation. So I have one very small report, but there was a drone that was flown there on October 3rd. It seemed like a long time ago, as I recall, I was flying. It was very nice, I'll say. So it has a little bit of information. URL. Didn't have time to make it clickable, which would be more convenient, but I can go to that. So what happened is somebody can write a report. We can look at the frame. The frame knows its location and orientation. So we can use that to go out and grab data from other sources. So here we're just using some simple ones. We have Bing, we have Google, some of those things. This is actually, what the heck is it? Panorama? You can look at some open source imagery that's been taken around there. So somebody else in that area has already taken some imagery or some other product. You can actually find it. So this has Street View up there. Pretty simple, but the idea then is this stuff came from the drone. Just one idea of what you might be able to do with some of the drone data. You can find it. You can find a very specific area of the mission that might be of interest, and then you can go out and grab a bunch of other data that might be. So that's looking at ISS. So we can do some other searches. Like I was at Goss's Park and I smelled something funny. I do a search for that. I say, hey, something happened at Goss's Park. And there was a strange odor. So what could that be? I'll go and look at the drone mission.
On your seats.
But there's some teenagers over there on skateboards. You never know what that means, but it can be a lot of different things. Then you can get, an overall, hey, there's a picture up there that's actually kind of pretty close. So what could that be? Some other kid on a bike looks to be about teenagers. Not quite as, never know, but I'm not judging anybody. But you can start putting things together. You can think of all the ways that this can put together. So is this happening in other parks? We can go and look. Colorado Springs, say, hey, is there any other parks, any imagery? And, nothing came up. We had gossip, but that's about the only thing that came up. Now, I, as an analyst, actually know that there was a mission flown in the park. They didn't put in the proper information. It was at Cottonwood Creek, so I can go find that. All right, so we have a Cottonwood Creek mission. And we also have some derived information that comes with that. So here's another mission. I don't see any problems here with the teenagers, but I do want people who are out there searching for parks, like Goss's Park, to be able to find this. So this is where some of the tools and topics are about. I can tag this. Let's say, hey, put this in with parks and add. Now I go back to search. You can see some of the tags, parks. I have to get rid of this. Not just got me free. If I search for park now, see that it came up. So that's value-added intelligence after the fact that people using topic builder can add to a lot of the missions that are going on. Okay, so some other things. I just showed you, extractions from images, but we can also. What about Garden of the Gods? Was there any drone footage of Garden of the Gods? Well, what do you know? I think there was some drone footage of Garden of the Gods. I'm sure I know who didn't take drone footage. But if we go and look at this drone footage, somebody did. They did not get the memo. I don't know if you can see any people that are climbing on the walls that got buzzed by this drone, but I don't really blame them for not being able to, especially for video. I don't know if anybody ran across it. There's a website out there. I think it's called Travel by Drone. So people are just taking their footage they put everywhere, and they can put it on Vimeo or YouTube, and then on Travel by Drone they make a map of it. It's pretty neat. And if you had all those drones, and as soon as the footage came down, you automatically indexed it, and you extracted the path and put a little buffer around it. So if anybody goes into a map and says, I'm interested in this area, this time frame, they can tag that and find it, identify it, and then we're in a better situation to take advantage of
all of the stuff that we're gathering that might not even be valuable to people that collected it, but could conceivably be valuable to other people later in time. Just a lot of cameras. All right, so that's the talking motor portion of it. All right. So tactical. Some of the things that we wanted to do tactically with the drone. These are the smaller drones that you put out there that tactical reconnaissance observation, and this was interesting. Lethal miniature aerial munitions. So an example of a tactical engagement. I just use a tank because tanks are awesome. I don't brag about it. But this could work very well for infantry or any soldier, because obviously the safest place to be when the enemy is over here is behind where they can see you. So with an Abrams tank, your safety's down here, but you can't see anything, you can't engage. You can sneak up, so you turn it down with the fire control system on the top, that's the primary sight. You can actually see what's out there. And then once it's out there, you can go up and engage. You got to get clear to the gun. This is comparing it to the T-72. It shows our spectacular awesomeness. They have to go way up here, and there's chicken feed for them one. You can see that much of the T-72 is going to blast it. But even when it has to go up and look at it, you're still kind of exposed. And if you're infantry, sneaking up there trying to engage, even more so. So, you talk about having a drone on top of your car, popping it out there with parking. We could deploy a drone right off there that could interact with the fire control system on what the gunner can see, so that before they even have to go over the hill, they already know where targets are at and can be able to engage. So we're going to show kind of a demonstration on how that might look. This is one of our many missions that we ran. Tactical observation, what we're going to do is I'm going to simulate being an infantry soldier. And I want to look up over the crest of the hill. So I'm going to deploy the drone. It's going to rapidly spin around, identify this friendly. So that's already been evaluated. Now it's going to go over here because we have this hill slope high enough. I'm going to go over and look to see if there's any enemy. But the drone can pop up there fine, and you'll see it's observing two targets that are off in the distance where I'm safely ensconced down there. But just a general idea of how this thing can just pop up, see some information, and come back down without any the drone's getting pretty cheap, so you can imagine. All right, now, lethal miniature aerial munition systems. This is where we're getting into the creative portion of our presentation. So this is actually, I forget, the RFI is out there, but they basically want to be able to take drones and turn them into kamikazes at the tactical level. So you can send out small drones and they can kind of persist in the area, but they can engage individual targets. So we did that with our drone. Now we couldn't engage a person because I couldn't fool anybody into doing it. But we did simulate the mission. So this footage takes a little bit of time to get mapped up. You got to be careful. I mean, when you're telling a drone to kill somebody, you got to take your time and make sure that you know what you're doing. In this particular instance, this is going to be a directed assault, meaning that the soldier is actually going to give a command to the drone, and the drone will attack the target. Since we can't attack a person, we identify a tree who's going to act as our target. So as soon as I get a command, it turns around and attacks. Boom.
Real life, folks.
Yeah, I couldn't show the end because the carnage
Real
was
life.
much. But trust me, it took it out. All right, now, part and structure attacks. A little bit different. We're talking about tanks, personnel carriers, a building. You might want to go ahead and attack that. This got a little bit tricky. We needed some higher level of intelligence for the drone, because it needs to make a lot of different decisions, because this is autonomous. We're not talking to kill something. It's going out and picking the target itself. So Tim Porter made a network called Skynet. It's a neural net-based artificial intelligence. is going to be making decisions for a drone in this particular instance. Skynet's connecting up a little bit. There's some strange things there. I'm not sure. It's probably nothing. But we'll go ahead and look at this. So Skynet, our second mission, the drone is going to go out there and start identifying the entire target area. As it is scanning through there, all this information is put into Skynet. Skynet is going to be making decisions on the best way to attack this particular target. And as soon as it's calculated and made its decision, the drone is sent directly at it. You'll notice that it's kind of going sideways. It's identifying the perfect way to enter the building. So glass, not first glass. And that's how direct it. So that was Skynet control. Now, the micro-armed vehicles. Well, this is real. This came out of U.S. Air Force stuff. They're looking at having little tiny microbots that can go out there and engage individuals. This is kind of spooky, but it's actually, well, it's cool if we're there first. This is actually, the next one's kind of a strange picture. You can't show it really good, but this is kind of showing a sniper. One of these things sneaks in behind it, identifies as the sniper, goes ahead and takes the thing out. Now, we're not the only ones developing these things. Okay? So you can imagine that other governments are developing these kinds of technologies, so we need to be prepared then against these things. So the next mission, protect and attack. There's an enemy air micro vehicle out there that needs to be identified by Skynet and engaged. So this was pretty quick. It picked up on it really fast. As soon as it gets spun up, there it goes, identified, the micro drone, took it out. So this was even more impressive than the books because this is a stealth micro drone. I'm willing to bet hardly any of you actually saw it. But it was identified and engaged. So that concludes the creative portion of our presentation. The next thing we'll talk about is virtual situational awareness. Now, if you've ever seen the very large aircraft that fly like Predators, the command centers for these things look a lot like this. Okay? So this is actually, kind of awkward for a pilot in the sense that they don't have the typical situational awareness that you would have on an aircraft. You can't, when you accelerate, you don't feel it. When you turn, you don't feel it. You can't look out the side of your canopy to see what's going on over there, which might be kind of important if you're kind of in a low terrain area. So we wanted to look at ways that we could augment this kind of input so that they would have a better idea of what's actually going around. And one of the ideas that we've worked on in the past is the use of something like Google's Liquid Galaxy. Anybody familiar, heard of Liquid Galaxy? So Liquid Galaxy is actually cool because it's built into the Google desktop application that most of you probably already have. And the way it works is that you can have a network of computers. You can go into Google, I don't remember the exact place it is, but if you go inside the folders inside the Google installation, there's a configuration file. You can go in there and say, I'm the master of Google thing, and I'm going to transmit my location. And on that network, you can tell the port number too. On that network, you can set up all these other computers and inside this Google installation configuration. Say, I'm listening on this port, and I'm going to look at this area. So the effect is that you control one single Google Earth, but it controls it across all of these monitors and all of these computers. Okay, and you don't have to use Google Earth because you can build this kind of stuff yourself. It's just kind of cool to do it with Google because of all the content that's in there and because it's already kind of built into the system. Now, the way that the master communicates with all of the other Google instances, if you will, is it's just sending UDP packets. So it's just blasting out. This is what I'm looking at repeatedly several times a second. And the other Google just sync to it really fast. So you can hijack that if you want to send in your own UDP packet. So if you're receiving telemetry from a drone or a car right on that vehicle, you can inject it into Google Earth, and it would go ahead and show you exactly what you're looking at, but in a virtual environment. So if you're in an aircraft, this is where you have to use your imagination, because we've set it up before here, but it's kind of a pain. And see. But if you're actually flying a Predator, you're looking here, you can actually look off the side using Google Earth. Kind of get a general idea of where you're actually at and what's on the ground. Okay, so I'm going to do another demonstration here. Show you what that would look like. So imagine instead of just seeing what those guys were seeing there, you can actually see in general where your aircraft is actually at and be injecting intelligence data coming from other systems. So here we might have city data, we might have a dome saying, hey, look, there's a bunch of little drones flying around and you're crazy. You don't want to go in this area. You can identify, we got an area here, you can see jets, areas where you think there might be some enemies, areas where you think that there might be some friendly forces. Because this is just coming in the telemetry, instead of just the pilots seeing what's going on, kind of having an idea, you could have intelligence officers kind of peel off. I've talked in the past to drone pilots and said, well, let's say that you're following a car, you see it's coming up to like a built-up area. You don't know what's up there, but using this, you can have somebody peel off. It's more of an actual simulation using the same kind of visualization I'll do work. And go in and say, hey, you know what? If you put the drone in this path, you'll be able to continuously observe that vehicle because of the built-up areas. Just a lot of different things that we think would be very interesting to pursue up here. So went ahead and put that in there. This isn't as creative as some of the other things we did, and it's actually quite positive. So I think, I don't know, do this with other groups too. That's effective. Okay. That's what all right, so in conclusion, now what you're all thinking, the judges are thinking, how is it that we can overgive this to extent? It's just not fair. It doesn't make any sense. We understand. That's fine. If you don't, Skynet has been acting up. You don't know what might happen without appropriate levels of funding. Well, we'll see. So with that, I'll go ahead and close it off. Thank you for my time. I know copies will come fast. We are Space Cadets. My name is Brian Warren. This is Murtaza Kamal. Our third and honorary member is Robin Cox. Robin lost her mother the first week of our hackathon and was not able to participate in the level two. Early on, we decided we wanted to do tracking and tagging of potential threats, basically people, to identify terrorists, to find people that maybe, most wanted list or something like that. But we also had this
obstacle course we had to do yesterday, so I kind of split up and did the navigation portion, and Murtaza focused on video capture, and we kind of would jump back and forth if one of us was having a problem, had a hurdle, then we kind of pitch in and help out. And so now we'll say, so we saw how well the obstacle course went yesterday, but so the idea here is that we would be able to fly the drone or multiple drones around in an area and basically find faces in the crowd, save the images to or send it to a server somewhere who's doing the hard crunching, saying, yes, that's somebody we care about. No, that's not someone we care about. But then the drone can fly around, and a lot of times you can set up cameras ahead of time. But if it's an open area, there might not be enough places, or the cameras would be fixed, and someone who is a sniper would be able to go, okay, I've got cameras there, I'm going to set up over here, and they're never going to see me. But a drone would be able to fly around, spin, change altitude, whatever, and try to find all the faces, so that some other computing power can decide what's important. Also, geotagged images, the drone knows where it is and can assign that location when it's taking those pictures. The stream of video is huge, so we really only wanted to go, well, don't take pictures unless you find faces. We don't know whether those faces are important yet, but as long as it's facing the wall that started, we didn't want it to fill up disk space or clog the network with files or images if they weren't important. So now it's taking pictures of the wall. Not really anything happening. But now we'll come around. We'll start to find. Go ahead and turn them on. So that helps. So the files. Oh, sometimes it finds ghosts. So it finds ghosts there. So got there were ghosts, but now we can start to go. Always been demo. Actually, they identified them and come around. But basically, it's actually captured more than one face. It only shows what it calls the biggest face in a box. And so it will do that, but it's actually taking pictures. It's actually saving files anytime there are any faces. And so we can look around the files now. I see that it's picking up more as it goes along, and it continues to pick up faces. And then we can come back and it'll only find ghosts. But so that was the idea, and then these we're saving them to the file here, but you can certainly stream them to a bigger server. If we were law enforcement, we would have access to the facial recognition database in their servers to be able to actually analyze these faces and stuff like that. But I couldn't find a cop who would give me his law enforcement code to go in there and do that. So this is as far as we got. So go ahead and go down. Any questions? No. All right. Thank you very much.
concludes this portion of the hackathon. The judges will meet for a little bit. I'll walk through the award ceremony. See you in 4.